All right, so let's talk about charges. What charges do these guys make when they form ions? So any group 1 element, remember these guys all end in S1, so they have that one valence electron. If you do a Lewis dot diagram, it's one dot. What do they do with that? They kick it out. So they lose an electron, and remember if you lose an electron, you end up with more positives because you have less negatives. If you have 6 valence electrons, you end in S2p4. That's 6 total valence electrons. So what do you want to do? You want to get that P4 up to P6, so you have to gain 2 more, and if you gain 2, you have 2 more negatives. Nitrogen and phosphorus, these guys are in group 5. They end in S2P5. I'm sorry, P3. So the 2 and the 3 equal 5, S2P3. So if you have 5, you want to get up to 8, you gain 3, and you make a negative 3 because you have 3 more negatives. If you have 3 valence electrons, gaining 3 more is not going to help. Gaining 3 is only going to get you up to 6, so you don't want to gain 3. You're going to lose 3. You're going to kick out all 3. So that means you're kicking out your S2 and your P1 together. So S2, P1, they all get kicked out, and you lose 3 electrons, so you end up with a plus 3 charge because you have fewer negatives than positives. Iron is a D element. So when we look at the D block, we never count the D's. We always count the S's that come before that. So when we look at iron, it's 4s2, and then we get into the 3 D's. Any of those D's, 1 through 10, it doesn't matter what they are. We don't care about that because the third energy level is not the outermost one. The fourth one is, so we count S2. Now, we're going to say for now, all D block have 2 valence. What do you do when you have 2? You lose 2, and you become a plus 2 ion. Now, that's not the case all the time. We are going to learn the exceptions when we get into ionic bonding. But you don't need to know that. What was I going to say? The valence electrons are going to be 2 for now, and we'll see that the D block does a lot of weird things. All right, an element whose configuration ends like this, again, we don't count the D's, because this is the 4th energy level. That's not the highest, so we count the 5th. We always count S and P. Always, always, always. S and P together. So in this case, we've got 2 and 5, so that's 7. If you have 7, you want to gain 1, and you end up with 1 more negative. Always, always, always count S's and P's together. Even this guy, like we have S1. Say in your head, well, that's P0. There's nothing in the P. We didn't even fill the S, never mind the P. So we are a long way from being stable. But always think S and P together. All right, cation, anion. That T in the middle of the word cation should make you think metal, because there's a T in the middle of the word there. And it should also make you think positively charged. How do you get positive? You lose electrons. And then if you lose, you become smaller. So look at all of these atoms in yellow. Each one of them has lost electrons, and they all become smaller. So this is our unhappy atom, and this is our ion. It's fixed the problem. It's now stable. It's not neutral anymore. These guys are neutral, but they're not always happy. Like lithium's got 3 protons and 3 electrons. Not happy that way. It wants to give away an electron. So now it's 3 protons and only 2 electrons. Sodium is 11 protons and 11 electrons. It's unhappy. It gives away 1. It's still got 11 protons, but now it's got 10 electrons. So it's got 1 more positive. So these guys all lose 1 electron. These guys all lose 2. They become much smaller. And look at these. These guys lose the most. These guys lose 3 and become really small. So the more you lose, the smaller you get. Now over here, these are your anions. Remember NN? One's for negative, one's for nonmetal. All your nonmetals on this side of the periodic table, these guys are all going to gain electrons. And look at what happens. Here's nitrogen. It's got 5 valence. It needs to get up to 8, so it's going to gain 3. If you stick 3 more electrons in that electron cloud, they're all going to repel, and they're going to spread out, and we end up with a really big ion. So the ion is larger than the atom. Larger than the unhappy atom. All these ions, these guys are nice and happy because they all gain 2. So we gain 2 and they repel, they spread out a little bit, but not as much as if you gain 3. This guy spread out the most. This one spreads out some, and this one spreads out a little bit. Fluorine, chlorine, bromine, all these halogens, they gain 1. They get 1 more negative. and they become stable. So know what your ions do. All of your cations, they all lose, so the ion gets small. Your anions all gain, the ions get large, they get bigger. All right, how do we gain or pull electrons out of an energy level? Well, we need some energy. If I want to take an electron away from lithium or fluorine or potassium, I have to use energy. Remember, this is positive. The nucleus is positive. These guys are negative. So if I'm a thief here, if I'm another atom, and I want to go in and take an electron away, I have to pull it away from that positive nucleus. So I've got to exert some energy. It might be a little bit, it might be a lot, depending on which electron I'm trying to take or how close that nucleus is or how many electrons are in the way, but I still have to exert some sort of energy to steal an electron from another element's electron cloud. So you're always thinking of it from the perspective of the thief. So let's talk about going across a period. Now we said earlier, as we go across a period, the nucleus gets stronger. There's more protons over here than over here. So this nucleus is really strong and it's doing a really good job holding on to all those electrons. So if I'm the thief and I want to come in and I want to take this guy right here, I got to battle the nucleus. And that nucleus is super strong, so I got a big battle on my hands. I need a lot of energy. So as I go to the right, the thief needs more and more energy. If I'm on the left, I don't need as much energy. That electron's right there. There's only 3 protons, so I can probably steal that without too much energy. But if I'm going up against 9 protons, I need a lot more energy. Now, let's talk about going down. If I want to steal an electron from here, I need to use a lot of energy because that nucleus is so close. But if I want to steal that electron, look at how far away that electron is from this nucleus. That nucleus can't do a really good job pulling on that electron because there's so many electrons in the way. There's a big shielding effect. There's a lot more energy levels. The valence electrons that I'm trying to steal are so far away, and that shielding effect, the blocking of the nuclear pull, is really, really high. So this is easy for me to do. I don't need much energy. This is going to be hard for me to do. So the more I go down, the less energy I need. The easier it is. Less ionization energy. Less energy the thief needs to steal an electron. All right, we'll pause this one and then we'll go to the next.